Hey Josh.
Hello.
Um, so you want to work on the packet today?
Yes.
Okay. Um, the next one I have that I have not done is the AB6.
Yeah, well, I don't work on school stuff outside of this, so.
Okay. I'm gonna go ahead and screen share, just that way we know mostly where we're at.
I haven't even done my movie project for Walland
I have to do some of that still.
because
We
I
got
don't.
we haven't even sent in our clips yet. We found
The
some, but we just haven't sent them to her, so that's always
only
nice.
time I don't do things like last minute is when I get someone to do them with me. Like,
I feel that.
thesis. Like, I've gotten CERN to do like calls like this while we work on thesis.
Hmm.
Um, what else? College applications. I've done them with Cal.
Yo, we should do that. Just do college applications and scholarships at the same time, Sierra. Yeah, say hi, Sierra. Hi.
Hi,
Sierra's
Sierra.
here.
She
It's
doesn't
Wednesday,
exist.
my
She is
dudes.
fire. I wonder if the
Okay.
virtual backgrounds will work for me. I'm sorry, I'm getting distracted. What are we
No,
doing?
you're good. Okay. Yo, that's actually a really good idea. It's just Zoom call people and just do stuff with them.
Yeah.
That's actually a really good idea. I like that. Okay. So number 6. Let me just move that a little bit out of the way. Boom. Okay, so let f be the function defined above, which of the following statements by f are true. Oh, it's a piecewise,
Yep.
which means it is not differentiable at, wait, hold on.
Now, what I'm guessing is the top function exists everywhere except at 2, and now they made it so it's continuous at 2. But
Yeah,
that's just,
so,
wait, we can solve that.
wait, say that again?
0, 4 over 2, 4 over 2 is 2.
Mm-hmm. Did you say x equals 0, though, for that one?
No, I didn't say that. Or, I will, yes. If x equals 0, it'd be 2 over 2. If x equals 2, that's when you have your hole. So they just patched a hole, I'm
Yeah,
assuming.
okay. It's not a piecewise. That's what I said for a second, and we just need to find out. Okay, so they did make it continuous by putting in that f of x equals 1 if x equals 2.
I'm
So
assuming.
that means statement number 2 is correct.
Yeah.
Um,
I'm trying to like
let's see.
visualize this.
Which means that at x equals number
Calculator? Do you
2,
know?
huh?
You know if we're allowed to use a calculator?
I'm assuming no.
Ooh.
We can probably use a calculator to check ourselves though.
I mean, you're not wrong. I guess you're right. She like never lets us use calculators. Like use them like once every like week.
Yeah, I think last week was like the first time I've actually used a calculator this year for math. I don't like that, but thank you. Sierra says we are the calculator.
She has more faith in us than I do.
Okay, so so it is continuous, which narrows our answers down to B, D, and E. Okay, so I guess my next question is it differentiable? Well, the my
Mm,
gut
no,
says, what'd you say?
I don't think so.
What? Can you clarify for me what differentiable means?
Um,
I can look it up. I just
if
want to
you
make sure.
can uh, find the derivative, so every single point you can find the find the rate of change. The way she explained in class is, you know if it's differentiable if everything is smooth. If you have like your absolute value or you have a point that is not differentiable, if you have what else? Holes, those are not differentiable.
Sierra says tangent lines.
What about him?
What about him?
If you have like a vertical
Is she
tangent
like
line,
just
the equation's not differentiable.
Okay, if you have a vertical tangent line, the different
oh so give me
yeah.
another yeah
So asymptote, if I remember correctly, sharp points, holes, asymptotes
Yeah.
are all not differentiable. So I guess we need to determine if it is a sharp. Well, we know it's not a hole because
it's patched.
yeah.
It would be a hole if it was just a top equation, but they put a
So so if it's so now we need to determine if there's a sharp point at all. And considering the fact, let's see.
the only example of a sharp point that I know is piecewise and absolute value. So
And I
it's
don't see any
yeah.
absolute value or piecewiseness.
Yeah.
So now we need to determine if there's an asymptote.
Yeah.
And we know there's not going to be any, let's see. If it's vertical.
Because remember, we
Yes.
could, what's this thing? What's the word? Where you take the top one and then divide it out. That's just x plus 2, x minus 2. Because that's how we know it's a hole and not a vertical
Oh,
asymptote.
you're saying like use like actual like long division, right?
No. Okay, so if we plug 2 in here, you get 0 over 0, right?
Yeah.
So that could mean a hole or it could mean a vertical asymptote. If you take the top, take the numerator, factor it out, that's x plus 2 times x minus 2. Then you can cancel out and just get
X plus 2.
yes. And that's why we know it's a hole and not a vertical asymptote.
So we know that there are no vertical asymptotes in this.
I think it's safe to say, yeah.
Okay, and then horizontal asymptote is where it's undefined. So then that's the denominator equaling 0. And I think it's differentiable.
I think so too.
Which means our answer would be E.
Yes, I think.
Okay, do we want to check that real quick on the teams?
Yeah, sure. I can do that pretty fast just because I have one note directly, which makes.
Okay, I'll let you check that then.
Midterm review and answers, nope. AB midterm review answers, yes, this is what I want. And the PDF is sideways. Why?
Just think sideways. Think sideways.
Well, we're wrong. It's A.
It's A?
Evidently. Ooh.
Okay.
Crack my neck.
It's you know what it must be? It must be a jump continuity. Or it's not jump, it's a removable discontinuity.
Yes.
We're doing great. I'm gonna graph this.
But I would still think it'd be continuous though. Because
Well,
there
I'm
is
gonna
continuity, but that discontinuity is at x equals 2.
Yeah, but the thing is, you can have a point. So basically at 2, 1, you can have a point and it could be a removable discontinuity, which basically says it does have a point here, but it's not on like the main line. Here, I'm gonna graph this real quick. Give me just a second. Oh, yeah. X squared minus 4 divided by x minus 2.
Do it.
Okay. Yeah, so I'm getting an error message for at x equals 2, which is understandable. So
Because you'd be doing 0 over 0, which is
So looking at the graph though, so that would be, I don't know if you can,
I
Hold on,
can't
I
do
gotta like
it.
make sure my.
Here, I have my own calculator. I can do it.
Just look at the graph because it just looks like a line.
It does. I see that. It's very
Mhm.
linear.
So I'm guessing what if I also put in 2?
Oh, I figured
You figured it
it
out?
out.
What is it?
So we know the point. So the point doesn't exist, right?
Mm-hmm.
So and we thought that the that bottom part we thought that was like plugging that gap, right? But it doesn't. At x equals 2, it should be like 4. Like the limit as x approaches 2 for this graph, I'm pretty sure
So
would be
it
4.
is removable.
It is removable, but just
That's
not
why.
when x equals 2, it's not supposed to be 1. It's supposed to be 4. Does
Yeah, yeah,
that make
yeah. Whenever you look on it at a graph, in
Yeah.
theory, it would be that. So we know. So that's why it's not continuous because it still quote
And
unquote has a hole
yeah,
in the line. So
and if
that
something's not continuous, it can't be differentiable. That's why. That's why.
okay. I'm gonna star that just that way I remind myself to like go back and remember that. Okay, you ready for the
So I
next
can
one?
remind myself to remember. Nice.
Yeah, remind myself to remember. Okay, so if f of x equals e to the power of 2x times the no, tangent to the
Tangent.
negative 1 of x, then f prime of 1. So we need to find the derivative.
Oh god, this seems terrible. Okay, so this is product rule.
Yes.
Okay, so e to the power of 2x, the derivative of that is e to the power of 2x times that times tan x times arctan x
Plus the first times the
plus,
derivative of the second. So now we got to remember inverse tangents uh, derivative.
what is the derivative of inverse? I
Is
don't
it
know.
secant squared? I
I'm not
feel like it's secant squared. Let the record show. I think it's secant squared.
Well, I'm not smart enough to memorize these things, so I'm just gonna do it.
Okay. So I know the derivative of tangent is secant squared, but inverse tangent.
Derivative of the inverse trigonometric.
Okay.
Whatever. It's 1 over 1
Arctan.
plus x squared.
Huh?
It's 1 over 1 plus x squared.
Yes. You're completely right.
Well, I mean, I just Googled it, but you know.
Yeah. So that's gonna be x over 1 plus x squared. And then we need to simplify, which is just gonna be e to the power 2x times tangent 1 plus x plus e to 2x. Okay, so that's going to be e to the 2x x over 1 plus x squared.
Wait, hold on, what?
When you're simplifying the product rule
Okay.
for the second part,
Yeah.
so you have e to the power of 2x
Yep.
parentheses times x over 1 plus x squared. When you multiply those two together, you get e to the power of 2x times x over 1 plus x squared.
Why is it times x? So the second
Because it's
part
a
I thought would
fraction.
just be e to the power of 2x over 1 plus x squared.
Over. But where did that? Because it is 1. Oh my gosh. You're right.
Okay, cool. Glad we could agree on that.
I didn't take the derivative of x. That's what I did. Okay. So now we simplify even further, right?
I'm not sure how, but yes, in theory.
Okay, so. Oh, now we plug in negative. Now we plug in 1.
Yeah, I think that sounds like a good idea.
Okay, so that is what f prime of x equals. So now we do f prime of 1 equals going to equal e to the power of 2 times 1, which is just going to be 2, times tangent of negative 1 of 1 plus e to the
I
power
don't
of 2,
know this again.
1 squared.
Sorry.
E to 2 plus. Oh shoot, when does inverse tangent equal 1? That's gonna be when oh my gosh. It's gonna be square root of 2 over 2, isn't it? Which is okay, I don't know. Give me an instruction. Oh, I don't know my unit circle.
Oh, 45 degrees?
Yeah, I know it's 45 degrees, which is square root of 2 over 2.
Yeah.
So wouldn't the inverse?
I'm not sure what you're asking.
Wouldn't the? It's just square root of 2 over 2, isn't it?
I'm pretty sure.
Oh, it's pretty gosh darn close, yes. I'm gonna say it's square root of 2 over 2. 2 over 2 plus e to the base, which is the power of 2 over 2. Okay, so we're gonna have,
They both have the same base. Oh, that's convenient.
so e minus 1. So then we just do e squared and plus e squared 2. It's not. Is it pi over 2? Pi over 2 is 90, right? There's just 180 divided by 2, which is 90. Oh, I know the answer. The answer is
Hold
B.
on, don't tell me.
Okay.
Okay, you can tell me. Is it D?
It's B.
Okay, you're gonna have to explain it.
Okay, so I think about everything in degrees, unfortunately, instead of radians. So we know that tangent of 1 has to be 45 degrees, right? Well, look at your answer choices. We know pi is 180. Pi divided by 2 is going to be 90. Pi divided by 4 is going to be 45 degrees.
Okay.
So the only one that has pi over 4 is B. Mathematically speaking, yeah. Mathematically speaking,
I just don't understand where they got pi from.
because pi over 4 is tangent of 1.
Where did you get 4?
So you know how pi equals 180 on the unit circle?
Yeah.
So I always think about it 180. Half of 180 is 90, right?
Yep.
So that's the equivalent of just saying 90 degrees.
Okay.
So you half that again to get 45 degrees, right?
Yep.
Which means 45 degrees is pi over 4.
Yeah.
So instead
Okay,
of
you
saying,
misunderstood my question.
okay,
So I simplify here. Let me just speak out how I simplify this and tell me if everything sounds right.
Okay, I'm
So
listening.
we plugged 1 in.
Mhm.
So I got e squared
Yep.
times square root of 2 over 2
Mm-hmm.
plus e squared over 1 plus 1.
Yep. You're good.
That turned into e squared times square root of 2 over 2 plus e squared over 2.
Yep.
That turned into e squared times square root of 2 plus e squared all over 2.
Okay, you are correct. However, when
Then I just factored out an e squared because I could.
so your math is sound. However,
Awesome.
when you no, I know what you're doing because I did the same thing before I looked at the actual answer choices. So square root of 2 over 2, square root of 2 over 2. That is 45 degrees, right? That's your sine and your cosine, right?
Oh, and then pi over 4 is also 45 degrees.
Mm-hmm.
But in that case,
So let me pull out my handy dandy unit circle that I have.
I know the unit circle. That's not my.
Well,
Hold on. If this were to be, where'd it go? If this were to be pi over 4. Pi over 4, right? Pi over 4. Yes. So let's keep doing this. That is, this becomes e squared times pi over 4. This becomes this, which becomes, oh boy, that's a little bit complicated, but that's fine. E squared pi plus 2e squared. And then does that simplify to that? Not really. You know
Okay.
what? I'll just.
So if you think about it kind of like this, if you have e squared plus e squared, right? Well,
Okay.
it's almost like saying because you can just do the equivalent of 2e squared, which or e is just really weird, right?
Yeah.
So I don't know. I don't know how to explain it other than the fact that I am like 98% sure that's the correct answer because pi over 4 is 45 degrees and we know that it should be 45 degrees, right? Are you looking at the answer right now?
Yeah, how could you tell?
I don't know, just intuition.
Very wise. Where is number 6?
It's number 7.
Where's number 7? Well, it says it's D.
It's D?
Uh-huh.
How is it D?
Well, D is closer to what I got. It's not what I got, but it's closer.
I mean, I don't know. Do you want to like skip it and ask her about it?
Okay, so here's the thing. I got, for my answer, e squared times open parentheses pi plus 1 all over 4, which is very close to D.
Say what you got again. E squared times what?
E squared times pi plus 1 all over 4, unless I factored something, which I did factor something.
How'd you get the pi plus
That's
1?
still wrong.
How'd you get the pi? You know what?
So
I'll just
you know where in our so you know where I said e squared times square root of 2 over 2 plus e squared over 1 plus 1?
Yeah.
You write square root of 2 over 2 and write pi over 4.
Yeah.
So that
Pi over 4. Right.
turns in.
You're frozen. I can't see you or hear you. I can't hear you.
Oh, you're back.
I couldn't hear you.
Okay, so that gives you e squared times pi over 4
Yep.
plus e squared over 2.
Uh-huh.
So then I made the denominators the same by multiplying the right side by 2.
Okay.
I get 2e squared over 4. And then I combined them.
Okay.
And then that gave me e squared times pi
Mm-hmm.
plus 2e squared all over 4. And then I factored out the e squared.
I know what you. But
And then,
why?
and then that gives us something that's very, very close to the right answer, but not quite. That gives us e squared times pi plus 2 over 4.
Mm-hmm. We can ask her about it.
Wait. No, dang it, that doesn't work. I thought I figured it out. Wait.
I was gonna say if you could divide everything by that by 2, but that still doesn't work. You know?
Yeah.
Oh well.
I
We
mean,
can ask her about it.
you could take the e squared out, like all the like completely out of the fraction, but that'd give you pi plus 2 over 4, which
And you still can't divide that by 2.
so close. So close. Not quite.
We're gonna have to ask her that one.
That's so annoying.
Yeah.
Okay, that's fine.
Okay. You wanna do one more for today then?
Yeah, sure. One more.
Okay. Number 8. If f of x equals cosine of 3 of x, then f prime of pi over 9 equals. Okay, so let's first, I guess first we gotta find the derivative.
Yeah.
So I'm just gonna do that.
So cosine is negative sine, right?
Yep.
That's negative sine of 3x times 3, because chain rule
Yes.
equals negative 3 sine of 3x. And then we plug in pi over 9.
Yep.
So let me just write this over here. 3 sine.
Ooh, that looks like an A. It was negative
So that
3
becomes 3 pi over 9. And then 3 over 9 reduces to 1/3. So what's pi over 3?
60 degrees.
Yeah, 60 degrees. Or what we're working in calculus, so in radians,
And that is square root of 3 over 2. I feel like that's completely wrong.
No, I'm pretty sure that's right.
It is right.
So square root of 3 over 2 times negative 3. So that's negative 3 square root of 3 over 2. And I don't think we can simplify any further. So we look at our answer choices, and that is E.
Boom. We're good at
You are
this.
brilliant.
I'm just happy I know my unit circle.
That was fast. We did that fast. We did that in like 2 minutes.
We done did it.
Do you notice
Okay.
how we just finished 8? The next question is 11, and the question after that is 9. I hate that there's
Well, that sounds like a problem for next time.
not at all numbered correctly, not even remotely.
I mean, we did have like 3 problem number 3s, so there is that too.
Yeah, I'm just gonna keep scrolling, see what else is wonky.
Okay. Do you want to hold off until next time then?
Yeah. Oh, here's one. It skips from 28 to 77.
That makes me feel a little bit better. Now we know that there are definitely not 77 problems, but there are in fact less than that. All right, I'm gonna go ahead and stop recording. Or stop.
Yeah, just press the stop recording button.
Yeah. Hold on, give me just a second.